Hello, Golden Bears. Team Geo welcomes you to Snow Day Sessions. This episode, Angles of Depression and Elevation. We are the Fantastic Four. Mr. Frame, Miss McKinley, Mr. Forstall, and Mr. McCune. Not going to say who is who. We'll leave that up to you. Alright, well let's get to some geometry. Wait, how'd these guys get in here? Must be the Olympics on the mind. And if you haven't seen this movie, take the opportunity with Snow Day to go stream this one, because this movie is a classic. Anyway, how about a game to get us in the mood before we get to some geometry? A little rock, paper, scissors. You ready? Rock, paper, scissors, shoot. Scissored! Man, who is this guy? He's like the wannabe Monopoly guy. Well, I think he might show up again later. Let's get to some notes. If you pull out the PDF we emailed to you, you can follow along with us. Alright, well here's our situation. Joe Cool Shades is walking along and he sees his friend, badly drawn stick figure man, walking along the street. He wants to give an awesome high five to him, so he looks him in the eye, but all of a sudden, here he goes, flying in the sky. Mr. Badly Drawn Friend has been doing some tinkering in his garage and has made a jetpack. Unbelievable what you can do with a snow day off. Well, no longer he can look him in the eye. He's looking at him up in the sky. I guess that rhymed. Didn't even intend it. Well, that angle that Mr. Joe Cool Shades has to lift his head to look at his friend is what we call the angle of elevation, denoted here by theta. So it's the angle an observer would raise his or her line of sight above a horizontal line in order to see an object. In this case, Mr. Jetpack Man. Well, at the other end of the spectrum is Mr. Jetpack Man's perspective. He no longer is looking his friend in the eye either. He is now looking down at him at a certain angle. That angle we call the angle of depression. It's the angle an observer would drop his or her line of sight below a horizontal line in order to see an object. Let's look at an example. A bird sits on top of a lamppost and sees an observer down below. This guy, man, scissors again. The angle of depression from the bird to the feet of the observer is 35 degrees. And the distance from the bird to the observer is 25 meters. How tall is the lamppost? Anyone know? Well, here's a hint. We'll use our trig ratios to figure this out. Can you tell which trig ratio we might use to help us find the height of the lamppost? Anyone? Bueller? You should also watch Ferris Bueller's Day Off if you have the opportunity during the snow day. Let's think about this for a second. The height of the lamppost isn't in the triangle that you see outlined here. But if we redraw the triangle like this, it's now the height. Why can we do that? Well, we have parallel lines. We have a hypotenuse, still 25 meters, and this angle is 35 degrees. Now, as you all recognize, because you're great geometers, the hypotenuse is actually a transversal cutting these two parallel lines. So we have alternate interior angles, and we have 35 degrees at the base of the man. Well, what trig ratio would we use? You're all brilliant, so you came up with sine. Why sine? Well, because the lamppost is the opposite side from our angle, and we have the hypotenuse as given. So sine 35 is the opposite over the hypotenuse, which in this case is L for the height of the lamppost, over 25. Here's what our proportion looks like now. Let's multiply that 25 out, and if you have a calculator, go ahead and pause and work this out. Alright, you should have gotten the height of the lamppost to be somewhere around 14.3 meters. Way to go! Here's another game for us, rock, paper, scissors again. You ready? Rock, paper, scissors, shoot! Scissors again! Man, this dude. Here's another example, this time angle of elevation. An airplane is flying at a height of 2 miles above the ground. The distance along the ground from the airplane to the airport is 5 miles. What is the angle of elevation from the airport to the airplane? Well, we're using trig ratios again. So since you're all brilliant, can you come up with a trig ratio? Of course you can. Notice that we don't have the hypotenuse as given information, but we do have the opposite side and the adjacent side. So of course we're using tangent. In this case, the tangent of theta equals opposite over adjacent, which is 2 over 5. To solve for the angle, we're going to need to use the tan inverse function. So theta will equal the tan inverse of 2 over 5. Take a minute to pause and work this out. Alright, you should have gotten theta to equal approximately 22 degrees. Great job. You're well on your way to understanding angles of depression and elevation. So how about one more try at rock, paper, scissors? Rock, paper, scissors, shoot. Gotcha. Alright, well thanks for watching. We hope you are enjoying your snow day, you're staying warm, you're drinking some cocoa. Hopefully you're watching Cool Runnings and Ferris Bueller's Day Off and probably Star Wars. Those would all be a great idea. And when you get a chance, look at the homework, page 333. There's 5 questions there, and you should be able to handle it with ease after having watched this Team Geo video. So go Team USA, and we'll see you all soon. Feel the rhythm, feel the rhyme. Come on, Golden Bears, it's a bobsled time. Cool Runnings. Wait, who said that?